The software-defined networking and OpenFlow webinar was made possible by the sponsorship of Big Switch Networks. Big Switch Networks are developing an SDN application for network virtualization, and you can get their open source SDN controller called Floodlight at the openflowhub.org. You can find Big Switch at bigswitch.com.
This webinar is just one of many vendor-independent data center and virtualization webinars available on IPSpace. To learn more about them, visit ipspace.net. And don't forget that you get immediate access to all of them with a yearly subscription.
Okay, so moving right on along. So let's talk more about how OpenFlow works in detail. So what does the OpenFlow protocol look like, and how does it work? So first of all, an OpenFlow entry consists of three fundamental parts: a match field, a counter, and an instruction. So match field says, what am I going to match in a frame or a field? Some field that I'm going to do, right? Then as each field is matched, then counters can then update to provide feedback on what is the progress of this information. And then what you also have is you want to say instructions to modify the frame. Now this is very simply things, but let's look at that in more detail. So OpenFlow, first of all, is a signaling protocol that goes between controller to switch and switch to controller, by the way. It's actually an asynchronous protocol that's symmetrically run. When I say symmetric, it means controller to device, device to controller. It happens in both directions. It's asynchronous, so either side can initiate a conversation at any time as needed. It also specifies match and actions to be applied to a frame. So that is, a frame comes in, we say I want to match these conditions, and when I match this, this is the action that happens. Fairly simple. What are the match fields that we can handle inside of OpenFlow? Actually, there's a pretty wide range of practical uses for it. So far, you can match on the inbound port. You can look at some metadata inside of the fields inside of there. Things like Ethernet type, Ethernet destination address, Ethernet source MAC address. What about VLAN ID? So if you're actually receiving an Ethernet frame with a VLAN, you might want to munge it according to some. You might want to strip the VLAN frame and then send it across to another side before you reapply it. You can also pop labels or push labels onto the stack. Look at the MPLS tag, details like that. You can also munge on IPv4, v4, full range of data in the IPv4 header, that all the things that you might expect, TOS, ARP codes, stuff like that. And then you can also munge in deeper into the TCP header, the layer 4 headers, and ICMP. Now, just beware that OpenFlow, it's still early days. A lot of what we're talking about here will change as time goes by. I can show you what we have today, so we can match on a fair bit of stuff. You know, there's details on, even within the MPLS tags, we can match on outermost tags. One of the limitations of the current product is that we can only match on outermost MPLS tags, but this is expected to be solved in the future. Okay, so what about actions? So we said before that a system can have matching, you match something, and we've looked at what you can match for an inbound frame or an inbound packet. Then what we do is we actually say, well, what do we want to do with it? We want to apply some sort of action to it. We want to clear. Maybe we want to clear a bit, clear the TOS field, clear the CLOS field. Maybe we want to rewrite some data into the system, or we want to write some metadata. Right. So there's a second part of this, is maybe we actually want to perform multiple actions into the system. What I'm saying there is not only do we want to hit it just the once, we might actually want to say, actually, I see that's come in from VLAN 10. Therefore, I want to be able to then say, if it comes from VLAN 10, I want to strip the VLAN tag, I want to apply this class of service, and now I wish to forward it out this port. Now, to be able to do that sort of action, I need to be able to match and action several times at several points. So therefore, I use a pipeline process to do that. So I can actually say in table 0, here's my match action, then create a second table and do a match action, and then keep going until the packet is finally egressed. Yeah, we also have a situation in OpenFlow 1.1 where they talked about group tables. This is fairly sophisticated and perhaps not really suitable for an introduction to, but you could actually say, I'm going to deviate this because this matches a particular condition, then send it off to a group table where a series of actions can be put in. However, it turns out that this is not easy to implement in current TCAM hardware for silicon speed forwarding, so that is wire speed forwarding, and this is presenting some problems at this particular point in time. So the answer was that it's a great idea, and pipeline processing is very easy to implement in software. So if you are building a software Ethernet switch, you can change anything at any time because it actually doesn't have any chipsets to hold it down. You just reformat the data model. But it's turning out that for pipeline processing, it is a little difficult to implement in hardware, and this will be solved in future versions. I believe that the vendors and the OpenFlow people are getting together to solve this problem. OpenFlow also has an interesting way of handling statistics in that OpenFlow has counters. So we had three parts to an OpenFlow flow entry. That was match, action, and counters. So OpenFlow clients, or the data in a switch, will always maintain a counter. So whenever a rule is hit, it will match and increment some sort of counters. The interesting idea here is that you might not necessarily actually want to perform an action. You might just want to count frames. So you could end up using OpenFlow as a NetFlow or SFlow type engine, and it would be functionally equivalent. Now, those of you who are familiar with NetFlow, SFlow know that they actually eject a record from the fib. So NetFlow and SFlow monitors entries in the forwarding base, and when a flow is active, it will then say this is how many times an entry in the fib was hit, and then it ejects a record out the size with the source, the destination, and a bunch of other relevant information that is then collected by a collector and then analyzed more later. NetFlow has been doing that for some time. SFlow has become very popular. OpenFlow uses the same concept as NetFlow to achieve the same outcome, except instead of actually ejecting a record out the side and causing the CPU to spin to create those records, NetFlow just maintains those counters against an existing flow, and then the controller would then fetch them, or the device would send them to the controller, yet to be determined. So statistics, don't worry too much about the image. It's just me having some fun. But it seemed nice. It looked like a cute picture. Okay. So the OpenFlow controller describes the data delivery from the controller to the device and is conceptually operates like SNMP. So the controller sends data down in a particular format. The device receives it, handles it independently. It uses an SSL connection to make sure that it's encrypted, so you've got things like certificate management and more importantly existing code to handle the SSL encryption process, so we know that it's easy, it's fast, and it's easy to do. And importantly, SSL means that you can use XML formatted data over a HTTP-like protocol. There's also a controller discovery protocol so that the controller can discover what the network device is looking like, and the switch can signal back link and port state to the controller. It can say that a link went up or down, or that the port has been unplugged, or data like that. It has to be said that in this particular area, there are many features planned, and there are some gaps in practical things. So, for example, areas where they're working on now is you have a device which is there. How do you know what is the neighboring device? Because to build a forwarding table, you must know what is the device that's next to it, and what it connects to, and what it connects to. And at this point in time, OpenFlow doesn't answer those questions, but the people who designed it do recognize this, and there's discussions going on about an LLDP type arrangement which would feed data back during a configuration process so that you would know neighboring switches up, down, stuff like that.
To get more information about IPSpace webinars, please visit ipspace.net.